Okay, so now that we know what trigonometric functions are, we're going to step up the rigor level, and we're going to be able to solve with trigonometric functions if we have a missing side length. Now, if you recall all of the other ones you did yesterday, you were given the side lengths. You were just able to quickly identify the ratio. Today, it's the same thing. It's just you're going to have to go one step further and figure out what x is with the trigonometric function. So, you're solving for missing length with trigonometry. The first thing you need to do is determine the segments you're given. That means, what are you given? Are you given adjacent? Are you given opposite? Are you given hypotenuse? Because that's going to help you know what to use for SOHCAHTOA. Our goal, everything is related to SOHCAHTOA. I need to know, am I given opposite? Am I given adjacent? Am I given hypotenuse? Which one am I given? And then once I determine which segments I have, I determine if I use sine, cosine, or tangent. That's, again, SOHCAHTOA. And then I create equation and I solve. That's kind of what we did for our warm-up questions. That's a preview of what this is. So looking at this first one, I want to figure out what x is. I'm given a degree and I'm given two line segments. So since it's a right triangle, I can use trigonometric functions. And I need to determine which one, sine, cosine, tangent. So, given my 39, which segments do I have? Well, I have an adjacent, and I have hypotenuse. So, which one has adjacent and hypotenuse? Huh?
Sine, cosine.
No, sine is opposite hypotenuse. Adjacent and hypotenuse is cosine. So, I'm going to use cosine. So then I know cosine of 39 is equal, so it's adjacent x over hypotenuse 7. So cosine of 39 is x over 7. Then this is the one new step. This is not new. It just looks different because there's a variable there. Now you just get the variable by itself. How do I move this 7? Times both sides by 7. That's algebra. And it's just plugging into your calculator. So in my calculator, I'm going 7 cosine 39 is 5.4. I'm going to run to the nearest 10. So x equals 5.4. Actually, I think I showed one more step. X equals 7 cosine 39. That canceled out that 7. X equals 5.4.
Oh.
Okay? That's what to do. Next one. I look at the angle that I have. Here's my angle. You can't compare it to the 90 degree. The 90 degree doesn't give you anything. The 90 degree is only relative, so you know where the hypotenuse is. So I look at that 23 degrees, and it looks like I'm given adjacent and opposite. So I want to know which trig function deals with adjacent and opposite. So this is opposite in height. This is adjacent height. This is opposite adjacent. That's what I want. I want TOA. I want tangent. So then I set up the ratio. Tan of 23 is equal to opposite x over adjacent 6. Now I got to get my x by itself. So I'm going to move this 6. So I'm going to times both sides by 6. And you get x equals 6 times tangent of 23. And just plug it in your calculator. 6 tan 23. That is 2.5. X equals 2.5. It looks really fancy, but you don't have to do tons of stuff. The trickiest thing is being able to identify which trig function are you going to use. But it looks really cool because you have those tan and cosine things. It looks like it's super smart. Okay, the next one. Which angle am I looking at, 90 or 46? I want to say it more confidently. 46. I'm looking at the 46, and then I'm wondering which segments am I given in relation to 46. It looks like I'm given adjacent, and I'm also given opposite of 46. It's not hypotenuse, because hypotenuse is opposite the 90. So adjacent and opposite. Okay, so which one is adjacent and opposite? Using, here I'll just rewrite it. Using SOHCAHTOA, tangent is opposite and adjacent. So I'll use the tangent ratio. So tan of 46 is equal to opposite 7 over adjacent x. Now I got to solve for x. Do I want x on the bottom? No, I don't. X, you can't solve for x with x on the bottom. X has to be a numerator. So I times both sides by x to get my x to the top. That cancels out the x on the bottom, gets rid of that dividend. And I get x tan 46 equals 7. Again, looks super fancy, but it's just normal algebra. And what am I doing to x and tangent? Am I adding, subtracting, multiply, divide? Right here. What does it look like? It looks, right now it looks like multiply. To get rid of multiply, I divide. So instead of multiplying by tan 46, I'm going to divide both sides by tangent 46. Notice I'm kind of being random with parentheses. Doesn't matter. It doesn't matter if you put it there or not. So now I have 7 divided by tan 46, and that's equal to 6.8 rounded. X equals 6.8. Okay, the next one. Looks like I'm given adjacent and opposite again. My goodness. Whatever. So I identify the angle, figure out the segments. I'm given adjacent, and I'm given opposite. Adjacent and opposite, TOA. So I use my tangent ratio. So tan 27 is equal to opposite x over adjacent 10. Now what do I do? Times by 10. Yep. Times by 10 to both sides. And x equals 10 tan 27, which just means 10 times tangent 27. 10 tan 27 is 5.1 rounded. That's learning target number 1 that I have for you. My goal, if I give you a missing side length, you can create a trigonometric function and solve for it if you're given an angle. We're also going to solve, too, instead of side lengths, our next learning target is solving for missing angles. So I do just want you to notice that in everything that we've done on this first page and what we did yesterday, the angle was always given to us. 39, 23, 46, 27. But sometimes we're going to have to figure out what the angle is. It's almost the same process, except not. But what you want to do is set up the equation, which means what trig function are you going to use? Are you going to use sine? Are you going to use cosine? Are you going to use tangent? Okay? Now, how to set that up, you need to identify in relation to the variable which segments do you have. I do want to just let you know again, theta is an unknown. It's the variable for an angle. Unknown angle. So everything I'm going to say theta here. Theta is just an unknown angle. And then we're going to use the inverse key. So remember, everything that we did before is inverse operations. Like when I had 7x equals 21, the inverse of multiplying, dividing. When I had 1 over x equals 13, the inverse of dividing by x, multiplying by x. Inverse is raised to the -1 power. It's just showing a sign of doing the opposite. At this time, I want to make sure you know where your inverse trig function keys are in your calculator. So take a minute and find them in your calculator. Okay, so we're going to apply this concept here. So now I have an unknown on this first example. I have theta. I have no idea what theta is, and I need to figure it out. So with respect to theta, the segments that I have are opposite, and it looks like I have adjacent. At first I thought it was hypotenuse, then I remembered hypotenuse is opposite the 90, and this is connected to the 90. So given theta, I have opposite and adjacent. I need to know which trig function am I going to use with opposite and adjacent. Which one? Tangent. So here's what I say. I say tan of theta is opposite 4 over adjacent 13. Now, some of you might think you need to divide by tangent. You do not do that. You can go ahead and try it in your calculator. You could go 4 divided by 13 divided by tangent. It's going to tell you that you're crazy. It's going to be like, what? I don't even get what you're trying to do. Because you can't, a trig ratio is a ratio. So you have to say, hey, I know that the tangent of theta is this. I want to know what is theta. What is the inverse of this? So you hit the inverse button. You say tan inverse of 4/13. I'm sorry, you should have theta equals the inverse tangent of 4/13. So I'm going to hit tan to the -1, 4 over 13, and it tells me 17.1. So theta equals 17.1 degrees. That's my angle measure. Okay, now I'm going to look at theta again. Here's theta again. I have no idea what theta is. I identify which trig ratio am I going to use. So I see that I'm given adjacent, and I see that I'm given hypotenuse. So I'm given adjacent and hypotenuse. That looks like cot. That's cosine, isn't it? So COTA. So since it's adjacent and hypotenuse, I'm going to use cosine. Cosine of theta is equal to adjacent 12 over hypotenuse 13. Now I need to figure out what theta is. I can't divide by cosine because it doesn't make any sense. So I take the inverse of the cosine. So I say theta is the inverse cosine of 12/13. And that is 22.6. Theta equals 22.6 degrees. This bottom one here, I want you to put the 4 on the side. This bottom right. Look, I looked at the bottom right. 4 was on the bottom. I want you to put it to the side. Okay, again though, I'm looking at theta. I identify where theta is. I identify what segments I have. So it looks like I have hypotenuse